And welcome to Manure Monday, this February the 27th edition. My name is Andrew Barry, and I'm with Omafra here in Ontario, and we're glad to be back after taking a week off last week. It was Family Day in Ontario, and so I hope that you were able to enjoy some time with family and friends doing something fun, maybe in the outdoors in the Great White North. But yeah, we're glad to be back this week. 2 weeks ago, we had a conversation about managing weed seeds, and that was a great conversation. That one's posted now. And just a reminder, you can go to Field Crop News, that's on YouTube, and watch the ones that have been previously played and recorded. So check those out. Today, we have a great topic. We're thrilled to be looking at some value-added manure. So to start things off in the chat, I'd ask you to post, if you're a farmer and you are using some type of value-added manure, put that in the chat. If you're a farmer and you are actually making some type of product with value-added manure, put that in the chat. Maybe you're a researcher, you're involved in one of the academic institutions and been doing some research on this. Maybe you're a company that has products. Anyhow, this would be a good opportunity to post some things in the chat, because there's been a lot of work done on this and some really neat products, one of which we're glad to highlight today. So just a reminder, we ask you to stay muted, put your questions in the chat. We will circle back at the end and have a time for discussion and to address those questions. And I will post the QR code for the CEU credit at the end. So let me introduce our speaker. You can see him on the screen here now. His name is Vince Herbruck. And Christine Brown first met Vince and heard him speak at North American Manure Expo in Pennsylvania, and thought, wow, this is one we've got to bring for the folks to hear. So Vince is with Herbruck's Poultry Ranch.
Correct.
And ranch is not so much a term we associate with poultry in Ontario, but certainly the size and scale of your operation, Vince, I think that's an appropriate term in your case. Vince is the manager of the layer equipment at all the chicken barns. They have a facility in Michigan. They've got a new egg laying production facility in Pennsylvania. And I won't say anything more other than this is going to be interesting. You'll be seeing stuff on video and hearing about the products he's doing, quite a significant operation. So Vince, welcome, and take it over from here.
All right, I'm going to throw up my presentation here. So we're basically a egg producer, but we also dry and sell all of our poultry fertilizer as fertilizer. We're a third and fourth generation family-owned company. We started in Saranac, Michigan. We've actually got 4 or 5 farms in Michigan, and this one now in Pennsylvania. Obviously, we're based in Michigan. We're one of the top 10 egg producers in the United States with about 9 million birds. Like I said, we produce about 2.5 billion eggs a year, give or take, and we sell all of our manure as dried fertilizer. There's a big picture of we have quite a big family, obviously. There's, I think there's 5 members of the previous generation, which is the 3rd generation, and then the 4th generation. There's 6 of us of the 11 who are working in the family, and the 5th generation is well on the way. So what do we do? Obviously, we sell primarily shell eggs. We also sell a little bit of liquid eggs, but we also sell 100% of our manure as fertilizer. Obviously, we've kind of started out, we've been in the organic and cage-free market for a very long time. The majority of our birds are organic or cage-free, so they're kind of a higher value bird. We did that, obviously, so we have more cubic space per bird, allowing them to spread out vertically, engage with all their natural behaviors, but also better temperature control for the birds and distribution to help them protect them from natural predators and diseases. There's a picture of just some of the outdoor access we have. All of our organic stuff has outdoor access as well. So part of the way we accomplish this manure drying system that I'm going to describe here in a minute is we had to switch over to some of our equipment. We've been doing this manure drying system, very similar type of system, for about 25 years now, but ventilation wise, we weren't really happy in a cage-free environment with what we were getting. So about 4 years ago, we started working with a company in Germany called FK Poultry, who's coincidentally enough, the same family we've been working with for the last 25 years to manufacture a lot of this equipment. But it arrives in about 24 40-foot long cargo containers from Germany. Each system inside of each house has about 360 metric tons of steel, 40 metric tons of plastic, about 120,000 torque screws. Obviously, this is a very tall system. It's almost 3 houses within one. There's 4 miles of manure belt and about 2,700 tube lights, or about 4.2 miles worth. I don't know what that is in kilometers, unfortunately, for my Canadian audience. There's 9 tiers of living systems and 3 tiers of floors. But basically, the goal of this whole thing was to give us better airflow, less airborne dust, and better lighting. So what does this whole fertilizer cycle look like? And this is kind of what we, as kind of being a sustainably focused company, have always tried to encourage. We would like, if we can, people are delivering feed, they're picking up fertilizer on their way out. That's kind of always been our model of, we'd like to help encourage, the people who are growing the crops to help feed our hens. So what we've kind of developed and we've been using for a long time here is we have an in-house manure drying system, which basically we're taking that inside of the house in about a 3 to 4 day cycle. We're trying to reuse as much existing heat and ventilation in the building, and we're trying to eliminate as many harmful gases like ammonia or even the breakdown of the manure before it even can kind of start. So we're trying to slow down and freeze that whole ammonification process. So we had kind of, over the last 25 years, most of our houses have had some kind of tunnel ventilation system, which is pretty standard in most chicken houses. You bring in all the air in one side and you throw it all out the other. And with cage free, that throws out a lot of dust as well. So after several building renovations, we kind of switched away from that model. We thought, how can we slow down the air as much as possible so we can recapture most of that dust and stuff inside the house so it never actually leaves the house, and then we can add it into our whole product stream of the dried fertilizer that's coming out of the house itself. So we came up with this thing we call transverse uplift ventilation, which it's kind of complicated, but it's really about creating as much air through the house as locally to the birds, so the birds are no more than 50 feet from fresh air at any one time. We're trying to make sure that we're using that same air and the same heat that we're using to ventilate the birds to actually dry and dehydrate the manure, so we're not wasting any extra heat or having to add any extra heat to that whole process. So what does this really look like? Almost all of our ventilation is on the sides and in the interior of our house, and all of the fans are at the very top, basically. So we have an interior interstitial space, which basically allows air to come back down into the center of the building and kind of come into those very locally to where the birds are. The outside intakes along there obviously bring fresh air along the sides as well, and then all the exhausted at the top. But what was the whole purpose of that? The real purpose of that is to try to do what we're doing here, which is we call our accelerated feces dehydration process. So kind of step one, and we'll go through the video. I'll try to go through it here. So our laying hens, and this is basically a legend that kind of shows what's going on here, but this will show the whole system split out into 6 different levels, basically. So there's 6 different belt levels in every single one of these systems. So the hens will deposit that manure on a belt at about 70 to 65% moisture. And excuse me if it's a little bit freeze framing here, but you can see right underneath the hen. So basically underneath the hen, typically, it's about roughly 2 meters wide for this belt, which is quite a wide belt. But it runs directly under every level of the aviary system, and it gets pretty evenly distributed across that. We never let it accumulate for more than 20 hours typically. So we're basically take that's whatever is getting deposited by the hens, and then we're trying to cycle it through the house as quickly as possible. The step 2 basically is we're trying to compress that manure. We're trying to create as much drying surface as possible. So what happens when you compress out something like that? And you can see how wet it is there. That's from right underneath the hen, but typically less than 24 hours old. We want to make sure we're getting it as flat as possible. And we try to get it less than typically about a third of an inch, maybe 10 millimeters thick at maximum. I'll just let this play here for a minute, but you can see that's the first step of actually pressing it flat. The next step will actually press it even flatter. So after it goes through there, it goes through a series of pressure rollers where we're actually pressing it onto the back side of the belt, as well as making sure that it's as thin as possible. Like I said, that's all about the encouraging as much surface area as possible. And we basically pressing it into what we call chips. They're almost like flat little pancakes. Now you can see this whole system itself is about 34, 35 feet tall. So we have to then get that manure as we're pressing it together. That's part of the other reason we're pressing it, so that we can get it as compressed as possible and then get it to basically, it all has to come together at the bottom and we bring it to the very top of the system. And using all of that pressure, we're able to take it up roughly 30 feet to the very top of that system. But this is my uncle, unfortunately. We had a narrated version of this, but I thought it'd be a little easier if I just explained it. But basically, in this backside here, we're keeping those belts all pressed together within a very small area so that that manure doesn't fall out. So basically, all those belts basically have to be pulled to the very top of the system, which I said is about 30 feet up. And then we've got to split them apart. So we take those belts that have been pressed together, and you can see how it's kind of, we're using both sides of the belts here to get it up to the very top. But ultimately, we're just using those bottom, there's very top belt, but then there's 6 layers of belts. Basically, it's the same number of belts that are in the system. And this is the dry raw product, and they're split apart before, and we're trying to create as flat a surface area, little chips like that. And you can see how pressed flat it is like that before we even send it in the drying tunnel. And this, like I said, this is less than 20 hours old. We then send it into this drying tunnel here, which is literally the length of the whole bird area, which is about 422 feet in most of our buildings. So we send it into this drying tunnel, and this drying tunnel is, like I said, it's every single one of those belts is 2 meters wide. And you can see here that the birds are. We're basically constantly drawing, even during minimum ventilation, we're drawing air through that tunnel. And here's a look down to see in the actual drying tunnel itself. You can see the belts moving. They don't actually move very much. They'll go up there and they'll sit for 1 day, basically. And in every single one of these house, we have roughly, I think it's about, so every single house is about 8,600 square meters of drying surface area. It's almost the size of 2 American football fields. So it's a ton of basically open space that we're constantly bringing air across for just roughly, well, for the first pass is 1 day, but we'll show you the 2 other passes that happen after that. So basically, like I said, that air passes over each one of those belts. It's all dependent on the outdoor air humidity of how much actual moisture you can take out of it. But it's basically a giant dehydrator. That's kind of the thoughts behind it. We then take all of that manure and we basically let it sit there for a day. And after 1 day, the manure is about 20 to 25% moisture. We kind of discovered this is a critical step to conserving the nitrogen within the dropping and preventing any sort of biological process from actually starting, or the ammonification process, basically. A lot of studies that we've and other people have shown that, dropping, at an ambient air temperature you know, it kind of stops that whole ammonia loss. You don't really get the whole microbial process started. And we basically, like I said, after about a day, you can see how dry it is there. That's I was trying to get back in the video here. Yeah, but it's basically pretty much dry or very dry at this point, and there's no microbial processes really happening. But what do we do with it then after that? Then we basically take it and we send it back through the tunnel for another day. So we take all of those upper belts like there are up above it, and we recollect it on a lower belt to pass it through the tunnel for a second day, which basically this whole system will run, the whole length of the system will run through the system once per day. So one whole revolution. So we take that kind of, this is the polishing step. And typically this will sit, once again, it will sit, we break it up, anywhere that was stuck to the belt, we basically bring it back to the back of the house, we lift it back up for one more pass through the same drying tunnel. The manure is typically now at about 15% moisture, give or take. And we'll send it back through one more time just to see if we can get any more moisture out of it before it leaves the house. Oop. Apologies, some video lag here. We send it through one more time before we actually pull it off the belt to be removed and pelletized and further processed. You can see how dry this material is now. We often will have to add water back if we want to try and pelletize any of this stuff, because it's so dry at this point. And we haven't added any extra heat or anything else basically into that process. This is just the exhaust air from the building itself. See how dry that stuff is. We also have floor scrapers in all of our houses to remove any litter from the floor level as well. So we add that into the whole stream as part of as it exits the house. So what do we do from there? Kind of what we do from there is we bring it onto a heat treating and pelletizing system, which, as anyone knows who wants to use any of their manure on any sort of food grade crops, you have to do that. This obviously, we use a PATS conveyor to bring the dry material out to where it actually gets pelletized itself and further it's sanitized. And this is mostly done in the ground until it gets out to the actual processing portion of it. Obviously, we have a surge hopper so that if we have a breakdown, we can reprocess it. So after the PATS conveyor, we basically heat we take the product and we heat it up to 165 degrees Fahrenheit, which if it isn't dry already, we're basically drying it out even further, which you can see here. We have a couple of Uzelac dryers. We're actually building our third and fourth one here later this year. So it's been so successful, we've decided to just do it a few other places as well. But this is all in line with the chicken houses. So we have a couple of cyclones here. So after we heat it up to 165 degrees to kill off any sort of bacteria or anything that might have grown in there, we then have a bunch of cyclones to try to recollect any dust or other debris or material before any of that air gets exhausted out in the bag house to collect any pollutants or anything like that. We then take that really dry material and we pelletize it. So we take that we have a series of pellet mills, and we're basically just like any other pellet mills, you have a pellet die, and in order to change it from a granular powder form, to a cylindrical pellet shape, you need about 11,000 PSI in order to do that. And right here, these are all enclosed to reduce the amount of dust that gets kicked off from them. But we oftentimes will have to add water back to this to make a better pellet, but that'll often heat those pellets up to about 250 degrees. So to be able to handle that in any further form, we actually send them right into a cooler. Next, after we send them through the pelletizer, we send them into a cooler. We have a couple of bliss coolers here that we basically take that pellet and we're taking it from that high temperature down to ambient, or 1 to 2 degrees within ambient. Then we take that nice pellet that everyone's like, oh, great. Well, we actually break it up. So we actually end up breaking that pellet up, because that's what most of our customers want, is something that comes out of a field spreader a little bit better than, say, an actual pellet like you'd have some sort of like a feed ingredient or something like that. We then take that last crumbling step and we basically screen it out into a whole bunch of different products from there. We use fines, crumbles, and then large crumbles, and those are kind of what we end up trying to sell them. We've got a couple of nice screeners this is one most recent one we put in Michigan, but we're basically screening them out right into totes for the most part. Anything larger that's closer to a pellet form ends up going into a pile for bulk sale. But those are what the pellets look like typically when we're just doing pellets. Obviously very different form from what the normal chicken fluff, but we would normally used to sell. These are what the fines, these are what the fines look like. And the video is, there we go, fines, crumbles, and large crumbles. Those are the 3 other types of products we end up making from that pellet itself. And typically that's what a lot of our customers have wanted. So what is the result? We have very little odor from ammonification or breakdown of the manure due to microbial processes. A dried, sanitized fertilizer that's rich in nutrients and less harmful in runoff than traditional chemical fertilizers. This is kind of a breakdown. Obviously, we have a 4-3-2 breakdown in most of this fertilizer. It's pretty high in nitrogen. It has a slower breakdown than some other forms of chemical fertilizer. And then just kind of as a recap, we've taken that chicken manure, we spread it out over as large a surface area as possible. In just under 4 days, we take it from 65% to 70% moisture down to 12 to 15% inside our housing system. We then sanitize, pelletize, and break it down in different products. And all that fertilizer is sold to farmers and other customers. Okay, well, that was my presentation. I kept it in at, oh, I forgot the video was off here. I was making hand gestures and everything.
That's awesome, Vince. Wow. Very, very interesting. And so folks, post your questions in the chat there. I have a number that come to mind right away. First of all, I have to say, when you talk about, well, if we put it into kilometers, we're pushing 7 kilometers of belt.
Correct.
And like, have you had to replace a belt? Those things.
Yes.
On you?
Yes, we have. We normally get them in like a 1.5 kilometer roll. They're very heavy. This obviously is a little bit more intensive than, say, a traditional system where you're just running the manure out into a pit or to some sort of optisect system on the side to dry it. The belts, as long as there's a little bit of preventive maintenance, we generally can make those belts last about 10 years before we have to replace them. That's been our general experience. We've been doing this drying process for about, in this system, as well as some of the others we have from another manufacturer called Farm Automatic, we've been doing this drying system for about 25 years. So we've got a lot of experience operating it, but we do have a whole department that is what they do basically. But we're basically it's something most people see as a nuisance, which is the manure, and we're generating a profit off of it. That's our goal. So
take us back to, I imagine in the Herbruck Farms boardroom, there were some interesting discussions 10, 15 years ago when you were considering this. This is big dollars, a huge investment and time investment and everything. And it's a change in the way you manage your manure. So what were the primary reasons why you went down this path? And then the follow-up just being, do you feel good about where you are today, that you've done the right thing?
Um, yeah, I think the biggest motivator for a lot of our thinking was what's best for the bird. You know, that high ammonia environment and having, all of the off gassing and stuff inside of a normal chicken house, it's not really good for the bird long term. It's also, it stinks. One, our neighbors, we want to be a good neighbor to our neighbors. So anything we can do to reduce flies, kind of reduce the smell to anyone around us. Um, I mean, those would be the biggest things, I think. We were just looking for a way to accomplish that, but also still be able to sell this stuff as fertilizer, in the end. So I think that was the general motivator behind it. At least that's what my dad tells me, and he's semi-retired now. So
Right. So you're feeling good about this decision. This was the right
I,
move for.
I think so. I don't think we've ever, since we started doing it, I don't think we've ever really looked back and said, well, can we do something? We're always looking for what can we do better, to make ourselves better. But I don't think we've ever seriously considered looking at or going back and saying, no, this wasn't worth it. So in terms of, we just want to be a good neighbor to our neighbors. We don't, the nice thing about a lot of our farms, you'll smell the feed for our chickens, but long before you'll smell our chickens. So
Okay, well, and I did want to ask about that. I know you mentioned about the odor and the reduction and so on, but odor is something that every poultry operation can have a challenge with. And flies, the other one you mentioned, I would say we have more challenges in Ontario dealing with the fly issue than the odor issue. That is a huge issue.
yeah,
So you've really seen a change in that, have you?
we have next to no flies unless they're from some other form. Most of the time it'll be spilled feed or something else, but there's barely any flies from the manure itself.
Yeah, and you're
Because you've
moving.
because you've moved that manure through the system so quickly,
Yeah.
most of those microbial processes that have started or would have started by this point, once you get it below that 30% moisture level, you kind of eliminate a lot of those. So, which is what we've kind of always liked to, that's kind of always been our goal. So,
And again, if I saw that right, 4 days is
yep,
basically
4 days.
from
So basically it's,
deposition to fertilizer.
yeah, 3 to 4 days inside the house to it being pelletized and then broken down into crumbles. And it's basically, our goal is always to be, we need a safe, storable, stable, and saleable product. That's kind of what our philosophy on it has been.
Okay, so just on the technology, I'm also curious, was this the only option that you looked at, or are there other types that you considered, and what might they have been?
We looked at a couple. In fact, we have two big Dutchman OptiSec systems where if we weren't getting quite as dry of product, and typically when we have pullets, we don't get quite as dry a product either. So when we're raising birds from a day old to 16 weeks, the products we're getting out of there are variably different than what this is typically, because these birds are not, there's not as many feathers in this, there's not as many, especially with the pullets, you get a lot more wetter diarrhea, unfortunately. But generally, almost all of our houses are built this style now. We don't have any that don't have this form of overhead drying system in them. Um, the Big Dutchman OptiSec systems we looked at, the issue would be by the time we're getting it there and putting it into the system. One, it's very labor intensive to add it back into the system, but two, it's already started to break down by that point. So then you get the flies, then you get the smell, you get all the other stuff. So we looked at those, we tried using them. We have two of them in place right now. They're more of a backup in case something in one of the houses breaks down, but they're not really, I don't think we've really run them in the last 10, 15 years. They're just basically collecting dust.
Right.
But there are systems like that are alternatives that can do a lot of what this system can do with less potential investment. This is a lot taller system. It's all above the birds and using the actual ventilation. Some of those OptiSec systems, they'll build them alongside of a house and they'll basically cross ventilate the house, and then they'll bring the air across the opposite system. But unless you're cycling that manure through the system in less than a day and a half, you're going to get the flies, you're going to get the ammonia, the smell, everything like that. So that's been our big learning experience over the last 25-ish years.
So just one more on that, in terms of co-benefits, and particularly I'm thinking in terms of, the health of the poultry. Have you seen any impacts there? Your percentage of dead stock and things like that, and any change?
Well, the biggest thing is, and with chickens, is if there's high ammonia, you get a lot of, it'll harm the bird's eyesight. And that's for us, we want the birds to be producing eggs as long as possible. So, we want them to be as healthy and as happy as they possibly can be. So generally, yes, we've seen some good benefits from this. Obviously, there's other ways you could do the same sort of system. In fact, I know FK Poultry has a few systems in Canada already. I know that was one where I went and first looked at their systems were in Canada. So there's different variations on this system. It doesn't have to be as such a tall monolith as our systems are. But
okay, let's talk about the fertility aspect
Yep.
here for a bit. And you did mention some of that. You showed a bit of the analysis.
I can go back to that if you would like.
Yeah, sure. And I'm also, I'm curious. So you have some land, I assume, with your production facilities as well. Are you using any of this product on your own fields? Like, do you have a crop production aspect of it as well?
We used to. We don't do it so much anymore. Generally, we used to do a lot of our own internal farming, but we only can farm, 5-6% of what we actually need for corn. So a lot of this, yeah, we've had no problem selling any of this, honestly, this dried chicken fertilizer, especially with the issues that have kind of come up with the global sourcing of a lot of these, especially chemical fertilizers. So we're actually sold out for the next like 2 years on this stuff. So we're selling it as fast as we can make it, unfortunately.
Wow.
So, and obviously, since we've effectively sanitized it, it can be used on, human consumption crops. So that's the biggest thing for a lot of our customers.
And so what would be the farthest that it would make sense to transport this product then?
We haven't done it anymore, but we actually had customers as far away as like Vietnam wanting it as fertilizer and wanting it in containers and bagged. We did that a couple times and it didn't make a lot of sense. But most of our stuff ends up going as a base for other people's fertilizer products, basically. But
okay. Yeah, certainly the last 2 years have changed the dynamics around the value of not only commercial fertilizer, but all the organic amendments, manure included. So what the future brings beyond that will be interesting to see. But on the pelleting side, like, I noticed you said that more of your customers, maybe that was a surprise to you, that more wanted it actually crumbled as opposed to pelletized. Is that
yeah,
a trend?
I think that's been a trend simply because it's a lot easier to either use an agglomeration process, if you're making your own agglomerated product, or it's easier to use in a field spreader, so you can actually go out and spread it on a field. A lot of times you need a specific type of spreader to actually spread a pelletized product. At least it's been my understanding. I'm an equipment guy. I know, like, I'm an engineer. I don't really know the actual farming systems as well of how you'd spread that, but that's been my general understanding. Looks like we've got a question here too.
Yeah. So the one in the chat, I'll read it in case there's some that are just on their phone, and then you can answer it. Very impressive system. Thank you for sharing. May I ask about the heating fuel, in brackets 165 Fahrenheit, the source that's used? So do fuel prices affect any operations? Impressive to hear the manure product has been a good addition to the business. Any idea how far reaching the materials would go? Well, we just talked about that. And the nutrients clustered around the working area or getting farther, and it sounds like they're growing to quite a reach of an area.
So
So yeah, the first part there in terms of the heating.
yes, fuel has definitely been an issue. We use almost all natural gas for all of our heating. So here in the United States, that hasn't been as much of an issue in this region, especially in Michigan. It depending on how far out you secure your natural gas and how much of if you have a pretty consistent amount of usage, you can typically plan out a little bit further on what you're trying to do. And that's what we've been able to do. The dryer itself actually recaptures a lot of that heat. So it doesn't actually end up using as much heat as we thought. In fact, the dryer itself uses about a third of what it costs to heat a chicken barn. But
Mm,
because the product we're putting into the actual the sanitizing process, the drum dryer portion of it, is so dry already, we don't actually have to add that much extra heat to it because of it being, 12 to 15% moisture. We don't have to add a ton more heat there because we're not actually taking more moisture out of it at that point, if that makes sense. So to actually sometimes to get the right sanitizing temp, we have to add water back into it to keep it, to get that right temperature to kill off anything in there.
right on. A follow up in the chat about fuels is anything you're considering for the future in terms of other energy sources, green energy sources and such?
Yes, here in Michigan, we have one of our sites that is roughly 25% covered by solar right now. We have plans if we can find the right space for it. We've got a lot of fields around our places, so it makes sense where it's flat. We can do solar. We'd like to do that at most of our other sites here in Michigan as well. So
Right on. Um,
I might have some pictures of that, but I probably can't find them in time for
no,
the
no
end of this.
worries. No worries.
You just search Herbruck's and then solar, you'll find some aerial shots of it, I'm sure.
Okay. And is that ground mount or rooftop? Do you know?
Ground, most of it's ground mount. The issue with rooftop installations is honestly, once you get high enough off the ground, then you need all the equipment to get up there. You have to deal with any sort of roof, anytime you're going through the roof to actually mount stuff to the roof. Um, for us, it's generally ground mounted solar has been more economical because we have a lot of we got a lot of farmland around us, and we're also trying to keep for biosecurity purposes, trying to keep other birds from landing nearby. So ground mounted stuff has tended to work a little bit better, and it's a lot easier to tie into the switching equipment. Everything can be underground. You don't have
Right.
to run any of those high voltage lines through your own buildings. So generally that's what we've tried to do.
You mentioned at one point in the process going through when it's on the belts and it's drying, you mentioned feathers.
Yes.
Could you elaborate that on a little bit more? Is it an issue with the feathers? Are they just part of the process? Where do they fit in?
Generally, feathers for us have always been an issue. I mean, we tend to get them, they end up getting mixed in with the rest of the manure and becoming part of that pellet. So we try to capture as many of them as we possibly can because it takes a while for them to break down. Obviously, they're a protein source, and they do add some to that whole nutrient analysis you see there. But generally speaking, we don't have as many feathers. We don't do any sort of molting other than the natural molting that occurs during the pullet phase, from 0 to 16 weeks. So we don't have a ton of extra feathers, but we try to capture as much of it as possible and then mix it into the whole process so we get a very even nutrient profile on all of our products.
The last thing I have in my mind to go to is just again some of the economics. So
Yes.
if I can ask on the product itself, what's the cost of the product? So I'm a farmer, I'm in your state, and I want to buy the product. What am I looking at?
I think most of that's on our website. When we do sell in bulk, unfortunately, like I mentioned before, we're pretty much sold out on bulk
Hmm.
for the next at least year. Um, it, it it varies. I don't remember how much it is per ton. I think it's a couple $100 a ton. I don't remember, but it's it's cheaper than a lot of other fertilizers, but it's still not the cheapest, obviously. In terms of the upfront investment and stuff required to put this in, the system itself costs about 35% more. The building, all the other stuff we've got to do to kind of support it, probably 35% more than a normal, say, layer operation of that size. So this is an
Right.
upfront investment. Then all the maintenance that's required to actually operate it. So, but yeah, you might be able to find our current prices for fertilizer on our website if you're looking for it. It's just herbrucks.com.
Okay. And so do you have much storage and much of a storage facility on site?
So by law here in the United States, we're required to have 6 months worth of storage. We barely, if ever have more than, a week or two worth of product on hand. So, but we have a lot of storage space for it because we're required to.
Right. So somebody in the chat is asking in terms of the ROI on what's your timeline for the return on investment for all that you had to put out? Any estimate on that?
So for the chicken houses themselves, obviously we're mainly selling eggs. You're looking at 10-ish years. For the drying system itself, it was closer to 5 years. For the sanitization process, rather, it's closer to 5 years. So wasn't that bad, to be honest with you, but we've been growing quite a bit over the last few years. So that I'm not entirely sure on what the exact law is. I think it's something to do with the CAFO permits here in the United States.
Okay. Yep. Christine O'Reilly, you have your hand up. Go ahead with the question.
Yeah. Just on the question about price, I did a quick Google search of the Herbruck website. Because they're sold out, they don't have any prices listed.
Oh,
So I will stick the link to the fertilizer section in the chat, because it looks like they've got waiting list links there if anyone's interested. But sorry, Vince, there's no pricing on the website right now.
I haven't looked at it in a while myself either, so I'm too busy building chicken houses.
Well, it's a good problem to have when the product's moving out the door and you can't keep up. That's
Eggs and fertilizer.
Right.
We're having trouble keeping up. So
yeah, similar here on other fronts. So very good. I think unless there's any other final questions, I think that's excellent. Listen, Vince, really appreciate that, giving us an overview and taking us right inside the facility to see on those videos. That was excellent, and we really appreciate that very much. I'm just going to pull up here the QR code, and this is for certified crop advisors. You're welcome to click on that, scan that. If it does not work for you, just put your name and your code in the chat, and Christine Brown will take care of that. I do want to mention that next week we are going to be circling back to a topic that we talked about last year, and that was bedded pack barns. And this is not a repeat of that. It's actually new information. So really looking at, there's been a lot more work done here in Ontario, and our colleague Christophe Wand, who presented last year, will be presenting again this year, but really looking at optimizing the system, all aspects of it. What's the value of that product in a cropping operation out in the field? How do you optimize it? The sources of bedding, the volumes, and also partnering with some work done through University of Guelph that was looking at greenhouse gases as well. So this is definitely a build on what was shared last year. And so we hope to see you next week for that session. And otherwise, we'll say thank you for joining us this week, and take care. Have a great week. We'll see you same time, same place next week for compost packed bedding barns. Cheers.